video, you're going to look at how you can speed up queries using aggregations. If you're not familiar with aggregations, there's a blog called Keeping Big Data Big with Aggregations on the PhantomDB site. The aggregations not only speed up performance, but can actually help reduce the load that are on your underlying data source. So let's get to it. For this demo, we're going to use telemetry data from the howold.net website. If you're not familiar with this site, it allows you to upload photos, and we use APIs to detect faces and try to determine the age and gender of the faces in the photos. The site itself lets you upload photos in three ways. One is you can just choose the photos from the site itself, and it will go ahead and detect. You can also search using Bing, or you can go ahead and use your own photos. The data that we collect involves the browser that the user used to upload the photo, the type of submission, either the search, upload, or picking one of the existing photos, the operating system, the date that it happened on, as well as a user ID, the latitude and longitude determined by reverse IP lookup, the number of faces that are detected in each photo, and then each line in the table itself is considered a photo. So every time you upload a photo or you look at one photo, that will be an additional line in our fact table. So in order for me to get the number of photos that were actually submitted, all I need to do is count the number of rows in the fact table. All the tables that you currently see are in what we call direct query mode. This means any queries that we generate in Power BI reports will actually execute directly against the source data itself. The data for the Howwold site is in a data warehouse that's actually sitting inside an Azure SQL data warehouse. So if I go to the reports and I pull in here to see the number of photos that were actually uploaded and I drop it on here, this is actually executing a SQL query. And you can see it takes a few seconds. Remember, the way we get number of photos is by actually counting the rows in the photo fact table. Everything I put on here, if I want to break this out by the operating system, is now going to run a query. Every visual I put on here is also going to run a query. So I look at, let's say, the number of faces, and we look at that by the different browsers that were used. Now there's two different queries that run on here. When I click on one visual, it filters the other visual. It's going to run a query to now filter down the other one. So every visual I put on this page is going to run a query. Every time I click, it's going to refresh all those visuals. So a single user can generate dozens, sometimes even more queries. That's just a single user. This database itself happens to be pretty fast, but I'm the only one on here. So with a lot of visuals on here, things will start to slow down, and then as I add more and more users, it'll get even more and more slow. So just because the data can handle a single user, or you can get good speeds out of your database, doesn't mean you can't benefit from adding aggregations. Aggregations will mean that you actually do less work at the time the query runs, because you'll have done that work in advance by creating that aggregation table. So let's actually put some aggregations in here. I'm going to delete these visuals for now so we can come back and recreate them. We'll see how much faster they are. So we go back to our diagram view. Now the biggest things that make this fact table so large are the really low event information. So for example, we have the user ID on here. We have a session ID on here. We have the event date time. This is down to the second that the photos were uploaded. So if we just get rid of those and we keep all our other dimensionality on there, we'll actually condense this data down to something pretty small. So let's go ahead and start creating a new fact table here. Now, this is going to be our aggregation table. You can create the aggregation table in many ways. The aggregation table is really just another table stored at the aggregated level. It can be another direct query table. It can be another in-memory table. And you can create that table any number of ways. You can create it in your ETL process. In this case, I'm going to use Power Query to go create that table. So let's do a get data. We will pick SQL Data Warehouse. Now we have the different connectivity modes here. Everything else is in direct query. Now I could make an aggregate table that's in direct query as well, but in this case I'm going to choose to make this an import table. I'm actually going to put it in memory, so the queries that run against it will be really fast. So I have my photo fact table, the same one we imported before. This time I'm going to edit it. So first thing we're going to do is get rid of any columns we don't need. These things tend to add a lot of grain to the fact table. Don't need the exact latitude and longitude. We don't need the exact second it was uploaded. But we want to keep the browser, the OS, other things like that. The date it happened on. Then we'll go ahead and remove these. Now the rest of the columns, the submission method ID, the browser ID, the OS ID, the date ID, we're going to take these and we're going to make these our group by columns. And our measures, we're going to have a count rows, so we're going to call our count, remember the number of photos is the number of rows that were in the table. Since we're going to aggregate this, we can no longer count the rows at query time. We need to count them in advance. So we're going to call this photos. That's going to be a count rows. We're going to add another aggregation here for face count. This will be a sum of face count. Another one here for image size. This will be a sum of image size. We'll add another one here for processing time. Again, it'll be a sum of processing time. So we're not losing any measures here. I'll say OK. And now we have our measures grouped by the different dimensions. So I'm going to call this photo ag. And we're going to go ahead and load this to the model. So what we've done here is we've actually created what's called a composite model by combining data that's in direct query with data that's in memory. I'm going to create a new diagram here. We'll call this our ag diagram. And you can see we have the new photo ag. And let me take this and we'll put this right next to the photo fact. You can see the differences. Let's zoom in a little bit here. So we have the same measures, photos, face count, image size, but we've dropped out a lot of the details here. So I'm going to bring in all of our related tables. We need browser, we want date, we want operating system, and we want the submission method. Now these tables are all stored in direct query mode. You can see that by looking at the storage mode. Where this table is in import mode. Now when we run a query against an aggregation, we will run that query either entirely within the aggregation, in this case it would be all in memory, or at the source itself, all in direct query mode. We don't want to do a mix of both because that could hurt performance. So these tables as being all in direct query, we can't run them in memory unless we either put them in memory, but if they were just in memory, then we couldn't run them in direct query mode. So we have a new mode that's called dual mode, which means the table both exists in direct query and in memory cached. So I'm going to select all these tables here, and we're going to change the storage mode to dual. Now they're imported into memory and they can be used both as direct query or cache. Then we'll go ahead and create our relationships. So the photo ag is now using the same tables for dimensions as the regular old fact table. If we go to the all table view, you can see that. Photo ag, photo fact. And then we have our dimensions. But we have to do one more step here if we want to go ahead and use the ag table in places where we can instead of actually hitting the fact table. We have to create this as an aggregation. So we need to set up our mappings between the photo fact and the ag table. And once we do that, any queries that go against the photo fact table that can actually be answered by the ag table will be automatically rewritten and run against the ag table. Before we do that, we need to make sure the columns in the ag table that are going to be used as the columns in the photo fact table are the same data types. So image size here is a whole number, but image size here is a decimal number. So I'm going to take all the columns we just added, all the measure columns really, and I'm going to make them whole numbers. One thing that's nice about this new diagram view is you can do multi-select and you can change things all in one shot. So we've done that. Now we can set up our ags. So I'll click on the table, I'll say Manage Aggregations. That'll bring up our ag window. We won't go into precedence much in this demo, but with precedence, what that allows you to do is you can have multiple aggregations in the same model. And when more than one aggregation can be used to answer a query, you can decide which one comes first by setting the precedence. So all we really need to do here, since we're using the same dimension tables, all we really need to do here in order to set up these mappings is to really map the measure columns. Dimensions will automatically work because they're exactly the same tables that are in dual mode. So photos, if you remember, when we created this on the ag table, this was the count of the rows in the table. So what we're going to do is we're going to say that this can be used when someone does a count row of the photo fact table. We can use this column to get the answer. So anytime you use the count rows function on the photo fact table, it will actually then rewrite the query to sum this column. Image count will be a sum anytime someone selects the face count column. So face count column on the ag table will be summed anytime someone selects the face count column on the photo fact table. We'll do the same with image size. And finally, processing time. So now we have our ag mapping set up. And I come back here. And now I pull photos onto the canvas. Remember, it took a few seconds the first time to run. Well, now it ran against the ag table. And instead of taking a few seconds, it was instant. It didn't actually run the direct query against SQL. It hit the in-memory cache. I can put in some more. Let's put in the different dates. And you can see everything I do now is instant. If we fast forward a little bit to a little bit more of a finished report, you can see I have multiple visuals on this page with a different slicer and a slider. Every time I do something here, right now, all these visuals are updating by hitting cache. I click on this one here. This filtered down, hit cache. I filtered this one down and hit cache, and I filtered this one down and hit cache. Because right now we have browser, photos, the names of the week, the names of the days, and then the days themselves are all in memory. But what if I want to drill down? Not just to the days, but to the actual minutes within those days or the seconds within those days. So I can now actually do a drill down. I've put the event date time here under the day name. Now the event date time is not in cache, it's in direct query. So when I do the drill down here, I'm filtered on Safari. So what it just did now was for this day, For Safari, it ran a direct query against SQL to bring me back all the data. So seamlessly, I'm transitioning between direct query and cache, but I'm using cache whenever possible. Now, it also at the same time filtered down these other visuals for the same day I just did the drill down on, but these were all answered by cache. And every time I change these, now these were answered by cache, but this one was now direct query. Same if I go back here and filter this, and let's say filter by face list. These were filtered by cache, and again direct query down here. Now if I click on something down here, like a particular second, now every visual on this page is running in direct query. Now we can do some more advanced things here. Let me pick a particular time frame. There were 12 photos here. If I right click this, I can do a drill through the way I set up this report. And let me see the different latitude and longitudes. Remember, we didn't put those in memory either. Those are all in direct query. So I'll drill through the locations. And now it's going to plot the map. Now, the number of faces in that block was 22 faces, 12 photos, and 12 different users. Now, these two cards here all refreshed from cache. Actually, I take that back. Since we had drilled down to a particular second, none of those could be answered from cache. So everything on this page was now answered from direct query. But you can see the different locations. You can see the different stats about that time frame. You know, because we narrowed it down to such a specific slice of data, everything can actually run pretty fast here. We're not scanning the entire data set and trying to aggregate it and bring it back. So we actually get much faster response times for some pretty intense queries. I mean, we're doing a distinct count of our user IDs. We're trying to plot latitudes and longitudes. But since it's becoming a very targeted query, SQL DW can handle that very well. And without having to put all that data in memory, we can get some very fast results. So there you have a simple example of creating aggregations over a SQL data source. Now, there's all kinds of other things you can do, more columns, more sources, much more complexity. It is really a powerful feature that can save you a lot of time, and if done properly, can actually reduce the total cost of ownership of your solution. But give it a try. Let me know any feedback in the comments below or any questions you may have. Thanks for joining.